for basically I got my master's degree in biochemistry from the University of the Sciences, and so Michael's basically went to college and then dropped out, but I have all the college knowledge that he could want or desire, and he has all the practical woods foraging knowledge that I could ever want or need. So I'm like all theoretical when I first met him, and then he was totally practical. He was like, oh, why are you like studying this stuff? Why don't you just go out into the woods and collect it and use it? And I'm like, wow, that's cool that you do that, because a lot of people are kind of nervous to get into it. They're just like, they don't know what stuff is. It's hard to learn, it's hard to know, but I came at it from just a general learning of chemistry, and I was always just interested in chemistry. And then I got into college and I was like, all right, I'm going to major in chemistry. And then when I got to grad school, I was like, I really don't know what I want to major in. But I was going to a school that had many, many sciences, and I was like, I really like this class, Pharmacognosy. So Pharmacognosy is the study of natural products. I think I have this in here. So this is just a cool quote. I love this quote. I don't do drugs, I am drugs. We're just a bunch of drug molecules floating around, basically. So when I got into this, I got into it from theoretically like reading papers, like for my classes, writing reports on how people were using mushrooms and how they were incorporating mushrooms in their daily lives, whether eating supplements or just food as medicine. So I was just so curious when I got into it that, you know, people are taking all these pharmaceutical drugs with all these side effects, and when, you know, like, for example, Asian medicine has been utilizing these natural products for sometimes thousands of years. So I just was like, wow, when I first got into this maybe 10 years ago, it just was, I was always thinking, oh, you have a pain, you go to the doctor, you take Advil. You don't look at it from a wellness standpoint of how is your body responding to the environment. If you have a headache, you know, maybe there's something else wrong with you. Maybe you're imbalanced in something. You know, if you keep getting headaches every single day, instead of taking the Advil, maybe look into what's kind of causing it. So I kind of had just, my mind was blown, and ever since when I met Michael and he started getting into making the extracts, I was like, wow. You know, I've seen people use lion's mane now, and I've seen people use cordyceps, and I've seen people use turkey tail for cancer, and, you know, like lion's mane for, like, my friend's mom uses lion's mane to see better. So all these, like, different off-target effects, but because we don't really know what these mushrooms are doing, and they're different in everyone, but it's not side effects that you see on pharmaceutical drugs. It's not like major depression, diarrhea, or like all these like horrible side effects, like blindness. I've heard, you know, these mushroom supplements are more almost just bringing your body back to homeostasis and like creating a baseline of and allowing you to adapt to stress, which is called an adaptogen. So I'm just curious, how many people here in this room right now take a mushroom supplement regularly? Anyone? Does anyone? You do?
Yeah.
What do you take?
It's just a tincture of, I don't even know, my friend made it. It's an
Just
adaptogen.
like general, like
Yeah, I
mushroom
mean,
supplements.
I know there's like cordyceps and turkey tail and shiitake and.
Okay, yeah, a lot of them have like 5 or 6 in one, right?
Yeah, yeah.
And then what supplement? You said you take a supplement?
Yeah, I make the reishi tea.
Oh, the reishi tea? Cool. Interesting. Yeah, so there's a lot of different things out there, right? So there's pills and teas, and what we make, because we think it's the most bioavailable after all of our research, are mushroom extracts, which are specifically a spagyric extract. So I'll just show you. This is the line of products that Michael just came out with. He does the more than the lion's share on making these, but I'm more the consultant. So I consult with him about glassware, extraction techniques, all stuff that I learned in school, right? He didn't necessarily learn that anywhere. And he took some knowledge that I've known that I was taught in school and applied it with mushrooms he's been foraging in the woods for years. And we created this whole line of extracts that are probably some of the most popular mushrooms out there in the world right now. And this is just such an important part of the talk because probably not a lot of people know this, but we've gotten extreme blowback since we came out with this set. We've been dropped by 2 credit card processors, Stripe and Square, and it took me over a month to get a new credit card processor, and it's because Visa and MasterCard, all the powers that be, they don't want stuff like this out on the market. And when you are, especially the green one over there, the fly agaric, this is they call it ethnomycology. Like, this is an ethnomycological wonder that's been used for thousands of years by Siberian shamans, and like literally has led whole Siberian cultures like to their destiny, basically. Like, these shamans would take this mushroom and then decide what's best for the community. So it's out there, it's in a lot of cultures. There's like Mayan peoples, if you get food of the gods, they talk about this mushroom. Over time, it's just been, throughout the millennia, utilized by people. But what is it a competitor of? Xanax. So that's like a multi-billion-dollar blockbuster drug, right? So many people are on Xanax. Anxiety is one of the scourges of our generation now. I was fortunate enough not to grow up having anxiety, but now living in this slice of culture that we're in with the traffic, and me and Michael moved to North Carolina, and I came back here a couple weeks ago for the first time in like 6 months, and I've never had such anxiety. Like, it just was like a weight on my chest sitting in traffic on 695, and I'm like, this is like making us, it's bringing us back to a level of basic like animal instincts. Like, I gotta get over, you know, like people like speeding in and out, like, and it's like, what? So you can like get home, so you can like make dinner for your kids or whatever. You know, it's like, it's not like you really need to survive, but people are in the car, and like just being in the car generates anxiety. And we lived in a small town, 300 people with no traffic for like 6 months just now, and then come back here, I'm like, whoa, like it's a culture shock for just me. And people, you know, embedded and meshed in cultures like this, I have to drive, I did it, I had to drive an hour to my work. I lived outside of Philadelphia and worked in a research hospital for a decade. And I quit in 2018. And I worked there, and I traveled an hour every single day. And it was so mind-blowing, like now not having to travel for work, and like not having to put myself in that position, get up at like, you know, so early and like get home so late, and like I work harder than ever now for this business, but I'm doing it on my own terms, and I'm not fighting traffic to have to go to a place where I'm living someone else's dream. So these extracts are really, they're so controversial, okay? So winding back around, we need stuff like this. The fly agaric is a natural anti-anxiety medication that Big Pharma is so afraid of people knowing about. And like I said, we couldn't get a payment processor, card processor for like a month. And I contacted this lady. I'm pretty sure she's from like Latin American culture, and mushrooms are more accepted. Like, and the lady that I just happened to contact from this one company took a chance on us, and now we were just able to get a credit card processor again this week. So we were without one for, might have been like almost 6 weeks. We couldn't take people's credit cards because this is what we're selling, okay? So it's crazy out there. Pharmaceutical companies are running scared, like from this and stuff like kratom for the opioid population, which Michael also sells, but has to also be like very underground, even though it's legal. So fly agaric is legal also. It is illegal in Louisiana, and because of that, no one wants anyone selling it, because you can't prove that someone didn't take it to Louisiana or ship it to Louisiana. So it's a huge gray area right now. And we've had Etsy take our products down. Etsy took down the lion's mane spittoon. Why? I don't know. There's nothing in that that's entheogenic or, psychoactive like the flag air, but people don't like it. They want to take it down. Lion's mane's getting extremely popular right now. It's in all those coffees. It was just, Joe Rogan is like promoting it on his podcast. And people are scared. People are scared of this. Anyway, I have all this knowledge, right? So I'm on both sides of the coin. Like, I worked in the drug discovery industry for almost a decade, right? So I see the value of drugs in the drug industry, but they're also fighting against this world of natural products right now because they're afraid and all their patents are expiring. So when I went to school and I went to the University of the Sciences, I graduated in 2014, and I was going to go for this subject, pharmacognosy, which is the branch of knowledge with drugs obtained from natural product sources. So it could be a mushroom, it could be a sea sponge, okay? People get very novel natural products from anywhere in the environment, especially marine animals as a sidetrack because they're much more potent because they have to deliver their toxins in water and they immediately get diluted. So there's some very powerful, even more powerful than mushroom, natural products out there. And we just happen to love mushrooms, and Mushroom Life, we have other botanical products as well that we offer, but we really focus on the mushrooms. And we're certified to collect wild mushrooms in 7 states right now. So we also sell fresh wild mushrooms, but this is really what we love doing. We love this subject, natural product medicine. So here's just like basically like an old book about pharmacognosy. No one really knows about that word, pharmacognosy. I don't hear people talking about it a lot, but it's pretty cool because it's like any drug from a natural product source, right? So, I just want to give like a brief overview because a lot of people don't even know, like, when you draw this, like, what is this? Like, what does that mean? Unless you maybe took organic chemistry. How many people here took organic chemistry? 1, 2 people in a whole room. Okay, so this is like from my chemistry knowledge. I'm just gonna like teach you guys really quick what is this. Like when you see this on a drug, like say you're your birth control and they say like, this is what this is, and it's just a bunch of lines and H's and N's and stuff. So the corners here, anywhere there's a corner, either a point or an angle, that's an atom. So that's a carbon atom, unless it has another, like the N is the nitrogen, H is a hydrogen, and the O is clearly an oxygen. The lines are the bonds between the atoms. And for example, some of them are double bonds if they have 2 lines between the corners. And that's why this is like geometric shapes as opposed to just having a circle in there, because they're actually a representation of bonds between atoms. And this is, you guys didn't even know you're going to get some chemistry today, so I totally snuck it in on you. And then any point without 4, this is cool, any point without 4 lines, so anywhere the carbon you can't see that has 4 bonds, there's actually a hydrogen there. So like the one on the end, I wish I think I have my pointer. Like the one over there on the bottom next to the nitrogen, it looks like it has a double bond, and then it's the other bond is to the nitrogen. Well, that is actually, there's a hydrogen sticking off there because you can only really see it going to 3 things. So instead of drawing all the hydrogens on there, they just leave it off. So now you guys know how to look at one of these and like be like, what is that? And I think it's super important, and not everyone took organic chemistry. Does anyone know what this is? Does anyone recognize this? No? So this is the molecule, psilocin, which is the active component of the reactions. This is like more ways to draw the molecule. Like I said, sometimes when you would see all the hydrogens, it would be explicit hydrogens would be the way that you would draw it. So I have the long version of my talk, I go on and explain that a lot more, but I'm just gonna skip through because I only have a certain amount of time here. So here's just a diagram of a fungal cell here. It's a little bit different than a human cell, and they have vacuoles in there, which you can see is just an empty space. And just an interesting point is that as the mycelium becomes older, it gets less dense and it has more vacuoles in it. And that's another reason why you see a mushroom that's old is it's all blown out. It's because it's just making space inside of itself. So drugs, so getting back to drugs. So just that one little primer on chemistry there, and now we're gonna jump into drugs. So cellular signaling is something that's happening all the time. It happens in mushrooms, it also happens in humans. So when you are, basically anything you can think of, moving a muscle, this is what's going on. You're blinking your eye, this is what's going on. You're hungry. That's your ghrelin molecule traveling from your gut to your brain saying, oh, I'm hungry right now. This is the process of what's going on. So there's one cell sending out a ligand, which is just a small molecule, and then there's another cell with a receptor on the end of it, and it basically catches that molecule like a baseball in a baseball glove, and then there's a cascade down through the cell into the nucleus, and that causes a response. So whatever that may be. Transcribe some DNA. Oh, crap, this is a toxic carcinogen. Die. You know, like whatever it is. And then if the cell doesn't have no receptor on the cell, there's like no reaction because it doesn't have anything to identify what this other cell is sending out, basically. So yeah, I basically just explained that. So it's a signal, then it goes, there's like a lot, just a cascade down to the nucleus, and then it causes a response. And I think this is really important to learn because no one really tells you this kind of stuff, right? So, and I believe in you guys, and I believe that everyone can learn this. So this is just something I found on the internet, but the things that are involved here in those transduction signal pathways down to the nucleus are things like MAP kinase cascade, regulators, transferasers, histidine kinases. These are enzymes that cause other enzymes to kick something else off, and then that'll kick something else off, and then that'll kick something else off, and eventually it'll get to the nucleus. And that is how your body recognizes drugs, okay? No matter what it is. A Xanax or Muscimol from Amanita muscaria. And then this is just, I'm going to skip over this because you don't really need to know this, but this is like how, if it's a competitive or non-competitive inhibitor. This is like a really short version of a long talk. So I wanted to give you guys like a different perspective on drugs, I guess. It's not just, if I just did this talk where I could have just been like, oh, here's the mushroom extracts that we sell, and here's all the actions that they do. But you can go read that out on our table, right? So let me teach you something else that's cool. So antifungal drugs. So here's, this is like a fungal cell wall, okay? The beta-glucans that comprise the cell wall, that's what we extract for our extracts. Those things are these huge sugar molecules, and as opposed to some other plants and stuff that have the same structures but are connected to different places. Anyway, when you're taking a mushroom extract, one part of it that you're taking, the water-soluble part, it literally is, you're extracting out with this water, you're extracting the architecture of the cell of the mushroom out. So it's these cell walls, the beta-glucans that are comprising the cell walls that you're actually taking out and taking into your body. And a cool mechanism of antifungal drugs, so when you have like, you know, a foot fungus or whatever, and you're like, oh, I gotta get rid of this athlete's foot or whatever, this sucks. One thing they came up with, which is really cool, is there's this enzyme that builds the wall, okay, beta-1,3-glucan synthase. It basically just means enzyme that builds the cell wall. So they basically came up with inhibitors of this thing. so that the cell walls couldn't be built in the fungus, and that is how one method of how antifungal drugs work. So when you put something on your foot, you can know it's just breaking down the cell walls in the fungus on your foot, or whatever, any sort of. I think that one's specifically for foot fungus, which I have had before. Okay. So yeah, this is, I just basically said this. There's medicinal compounds in the cell wall. This is the water extract. So when you are making these mushroom extracts, there's a water extract a lot of times and an alcohol extract, and then they're combined. So the water extract, this is the medicinal component of it. It is the beta-glucans. And the wild mushrooms have way higher beta-glucans than cultivated. Because, for example, imagine sitting in a cushy room your whole life. You're not going to be like very tough skinned, right? But if you're sitting out in the environment, you're going to get like calluses and like sunburned and everything. You know, your skin and your body's going to build itself up a thick layer. That happens in mushrooms as well. So all I'm serious. So the wild mushrooms have way thicker cell walls, and that actually means way more medicinal components than cultivated mushrooms. And that's just what they look like in chemical form. That's like where it branches off. Alright, this is like kind of neat, but so so they've done a lot of testing on fruiting bodies that are just from nature versus ones that people grow in the lab. Or there's a lot of extracts that just use mycelium. So you got to be careful if the extract just uses mycelium. So if they're just saying, oh, we just use mycelium in our products, a lot of times people are like proud of that and they say that like it's a good thing, but it's actually not, because you're not getting any of that fruiting body that's normally what we're extracting from nature. It's just more of like the mycelium is not like the active part of the mushroom. So there's more beta-glucans in fruiting bodies and more alpha-glucans in mycelium is basically what this thing was saying. I'm going to skip over that kind of stuff. So the other component, so there's the water-soluble component, and then there's the alcohol fraction, like the alcohol-soluble components, and those are called the triterpenes. And they're not water-soluble. They're secondary metabolites, which means in the fungus itself, when it's in nature, it's manufacturing things, antifungals, antibacterial, antimicrobials, just to say a lot. Those things, when we extract them, they actually help our bodies because they're also antimicrobial, anti-tumor, and they can even be, I put on here, radioprotective. There's certain reishi mushroom strains that have been shown to protect your body from the damaging effects of radiation. For example, you know, at people that take them after, like at Fukushima, a lot of Japanese people take medicinal mushrooms to protect them from radiation, which is wild because we don't have to really deal with that here, or no one really thinks about that. Okay, here's another really weird thing. So they've learned that, so one, thinking how can mushrooms help us, not necessarily with, you know, extracting them. So there's a compound they found here from this xylaria, which is called the dead man's fingers. They use this, it's really not soluble in water at all, but scientists have extracted this compound from these weird xylaria mushrooms that grow in the rainforest, and they've conjugated them to silver nanoparticles, and they use them for drug delivery. So this is like an example of something that it's not necessarily a mushroom helping you directly, but it could be used in another way to deliver, basically to kill cancer cells and right in your body without hurting it, which is, I just thought was like amazing when I saw the study. I was like, what? They're using this, you know, as a nanoparticle. It's crazy. So this is some more examples of some natural products. They all look really different. Some are big, some are super small. The one in the top in the middle, Illudin S, that's a natural product from Omphalodus illudens, the jack-o'-lantern mushroom, the one that's like bright orange and glows in the dark. They're just all, this slide basically says Mother Nature is the best medicinal chemist because we could not even make this stuff in the lab. Even if people sat down to synthesize this, it's such complicated structures, they would never come up with it. But these are the bioavailable structures that our bodies can use, which is like amazing. Okay, so this is a cool story. Alpha ammonite is a cyclic peptide, so that just means it's a peptide, which means a string of amino acids. So it's 8 amino acids. They happen to be combined in a circle. And this is what kills you from the deadly amanita. It's a non-competitive enzyme inhibitor of RNA polymerase, so it basically stops cells from dividing because it stops them from transcribing RNA. And it non-competitive means it doesn't act at the site, it acts somewhere else on the molecule, and it basically just makes the RNA polymerase like completely inactive and change shape. So this is what kills you when you eat a deadly toxic Amanita bisporigera mushroom, the white angel or the deadly angel. This is the thing that's actually killing you. And now you guys know it's a bunch of points of carbon, right? Because we like went over that with different bonds. So they were like, oh, we can't make it. We want to study this, but we can't make it at all because it's so complicated and it's like spun in a circle. So synthesizing this molecule in a laboratory was completely impossible until last year. Last year they did it. It has an extremely complex structure. Yeah, American Chemical Society did it last year. And why would they want to do it? Why did they want to do it? Why did they need to make this one natural product? They wanted to use it to cure cancer. So just like the last thing I showed you where they're conjugating a mushroom to a nanoparticle, what they're trying to do here was bind alpha-amanitin to an antibody that would be against a tumor. So when it's an antibody, they say against something. So it's an antibody that has been made to recognize something. So they're like, how are we going to cure pancreatic cancer? Is like one of the worst killers of all the cancers. So they're trying radical methods now, and they think what they came up with last year, which is completely amazing to me, is they're making antibodies against the tumors. So they're taking out parts of tumors, they're making antibodies against them, and then they're conjugating this extremely deadly toxin against them and putting this into mice, and it's selectively targeting the tumors and then not targeting anything else in the mice's body and actually killing the tumors. So this could be like they don't want to try it in humans yet because it's so deadly, but this is like promising cancer medicine. Again, using a mushroom in a really weird way. So I said we're not just going to talk about, I actually have the link right here. I think they're starting human trials as of last year when I made this presentation. So drug discovery, the whole spectrum of drug discovery from identifying what you want to make a drug against to FDA review and approval is like at least 12 years. Sometimes it's 20. So where I was working in my lab was the second one, assay screening. So we would try to construct these really weird, it basically was like cells and test tubes, and then we were trying to test drugs against them. And it just wasn't very effective, and nothing was getting past that point. So we were never going to make it to 15 years and have a drug. And there's there's different ways of telling could something be a drug or not. So if its molecular weight is less than 500, if it doesn't have more than 5 hydrogen bond donors or 10 hydrogen bond acceptors, and if it's like not super greasy, which is what the last one is a measure of, then it could be a drug. So they have all these things out there that say, like, what does a drug look like? And it has to fall within these certain parameters, basically. So scientists estimate the total number of drug-like molecules is more than the number of stars in the night sky. And then this guy who's like a consciousness researcher that I saw talk, he's like, to make the future even more interesting, those billion new drugs waiting to be discovered don't take into account the potential advances in neuroscience and nanotechnology, which I just told you guys about, that may allow us to engineer even newer brain structures, expand our own brain chemistry, and increase the range of our neurological abilities, allowing for even more amazing and incredible stage of consciousness to become possible. And psychedelics are back, right? Like we just heard the Johns Hopkins guy talking. I'm not gonna say what he said, but like, this is it. They're back. Psychedelic research is back. Peer-reviewed, double-blind, institutionally based, and federally sanctioned psychedelic research is back. It was gone for years, like almost 40 years. This is probably what the guy before me just talked about parts of the brain communicating that were never communicating before as a result of the Johns Hopkins study. They can be used to discover new pathways in the mind, these psychedelics. For example, Amanita muscaria, the one that we make, which is our only psychedelic. It's not really even psychedelic. It's not even really the magic mushroom, but it's anti-anxiety. But it can be, what's it called? It's like, it can be euphoric. So there's all these different words, right? So I think this is like cool. This is like a good thing for people to know. So psilocin, the compound that I showed you earlier that's psychoactive, look how close it is now that we know what a structure looks like. So this is why I taught you guys this. So now that you know, like, these all look almost so similar, right? So psilocin, DMT, look how close they look to melatonin and serotonin and tryptophan. They're so close. But the two on the right are illegal. But the ones on the left are in your body all the time. So it goes back to my first slide, like, I don't do drugs, I am drugs. Like, they're very similar. Like, they have almost the same structure, guys. Like, these things are so extremely similar. So, food for thought. There's structure-activity relationships. There's a lot of different, the structure of the psychoactive resembles that of the neurotransmitter. So, it makes sense, right? Because why else are these psychoactive compounds able to affect our brain so much? Because they look just like the other signaling molecules that are always in our brain. Almost exactly like them. So the analog is the movement of a single atom from one position to another. And it can go from like feeling like nothing to overwhelming, completely overwhelming. And this is just psilocin, and then R1 and R2 in the second structure over here. Depending on what you change those to, if R1 is H and R2 is also H here, that's tryptamine. But if R1 is OH and R2 is H, that's going to be a compound called 5-HT. You add a phosphate onto that, that's what those people take, 5-HTP, for regenerating their serotonin, right? Everyone's probably heard of that. So that's how similar they are. They're just one or two little hydrogens or whatever away from being a new, the same structural class. And then the ones under tryptamine, like the ones at the bottom, those are research, what they call like research chemicals right now. Okay, here's another cool structure-activity relationship, non-psychedelic. So there was an accidental discovery made In 1928, Alexander Fleming's lab assistant accidentally left a window open overnight and mold spores covered his Staphylococcus specimens. Whoops. And at first he was like really pissed off and he was like about to throw them away. But then he realized that all the bacteria that was like surrounding them were dying off. So he was looking at them under the microscope and he realized that, wow, I basically have an antibiotic, and it was the first discovery, accidental discovery antibiotic. So this beta-lactam antibiotics were the first, first antibiotics, and they're from a yeast, which is technically a fungus, right? So here's some more beta-lactam antibiotics. So when you take an antibiotic, you're probably taking one of these, probably one of these structures. Very, very similar. And they're all derived from a fungus of sorts. Now they make them synthetically, but they use that first basic component, this structure right there, and they just went hog wild. And then as they're creating more and more of these, the bacteria are building up more and more resistance to them. So they have to keep creating more and more and more. Yeah, so this is the most widely used group of antibiotics, is what my note says. More than half of all commercially available antibiotics are the beta-lactams. So this is like an accidental discovery that made pharmaceutical companies like billions of dollars over the years. Taxol, another blockbuster, probably the most blockbuster fungal drug out there in existence for cancer. The only source they used to have was Taxus brevifolia bark, which is this like tree down in the South American jungle. It was really hard to get Taxol out of it. They always had a low yield, it wasn't really worth it. 1 kilogram of raw Taxol required 10 tons of bark. So they're like, oh, we gotta cut down thousands of these trees so we can get this cancer drug that was amazing. This was in like the 60s or 70s. And they didn't realize it, but there was a endophytic fungus that was discovered that was producing the Taxol in the trees. So it was an endophytic fungus living in the tree, which is why they couldn't figure it out for years and years. So it was the best cancer drug ever on earth that's still used. It's like the staple in breast cancer, I think, to this day, is Taxol, and that is another fungal natural product. And then now they use a method where they ferment the fungus now industrially. And then this is just this is the Taxol molecule. It looks a little complicated. However, I ran across this thing, it's really cool, thing that they're telling you. So all the other drugs they've made, this is what they've learned. They learned that, for example, the one group in the corner right there, the N-acyl group, is essential. It will lose functionality if you take this group off, okay? It won't be a cancer drug anymore. And they went all around the molecule and they tested different things at every position over years and years, and this is what they've come up with. So this is what they've learned all about this molecule because it's so important, fungally derived molecule over the years, and by just tweaking it little by little, and then they've learned all this stuff about it. Awesome. So, okay, this is the fly agaric thing that I was telling you about. This is how close the structure is to GABA, which is your gamma aminobutyric acid or whatever. And that is your receptor for sleep. It's the anxiety receptor that Xanax hits. So close to muscimol, which is the active component of Amanita muscaria. And that is why they're like, so let me rephrase. The natural transmitter in your body, GABA, is very similar to the active compound muscimol in Amanita muscaria. And the drug companies know that, and they can't make a better one because the mushrooms already made it, and they're like, fuck you guys, basically. So this is just like a little thing, what happens when you eat Amanita. This is probably caps, I think. you ingest, you can have kind of warping of space-time. This is eating the caps, this is not our extract. And then eventually you become tired, and then pretty much go to sleep. It's actually way better and safer than Xanax, where people become zombies. Here's another cool one. Yeah, so this is they discovered this last summer, like 2 weeks before I gave this talk last year. So some species there's entomopathogenic fungi that eat insects. Some of them keep them alive and drug the bugs as they're fruiting. So they drug them with amphetamines and tryptamines. So, and it makes the bugs more sexually active, which spreads the spores of the fungus, and it increases their endurance, so they can travel further away and spread the spores. And it suppresses their feeding prior to death, so that it's easier for them to pervade their body. And they try to copulate to infect other cicadas. And they're literally doing this it's like meth and mushrooms. They're basically so this is so cool though, right? They found out they're keeping these cicadas alive. This cordyceps type thing is keeping this cicada alive by drugging it up until the very last minute when it fruits, and then it's able to fruit and spread its spores out the bug. This is just an excerpt from the paper that I got it from. So there's all sorts of cool things you can do with bioprospecting, right? There's so much stuff going on in nature, as we've seen throughout this whole thing, and it could be used for anything, and it could be more accidental discoveries out there. Dyes, pest control, paper, pulp, pest control. If you get a bunch of cordyceps, you're not going to have ants, or you're not going to have cicadas or whatever around. They think they can use these things to positively benefit human society, basically. Also, eco-friendly alternatives because they're not using chemicals. There's just so many. I have so many more slides. I have 10 more slides on this. These are some cool. They discovered recently that lichens have fungi in them, so they didn't know that a lichen there was a fungus working in there. These are cool structures. They're not circular. They actually are multiple, I think it's a dodecagon or something. No, 16 member rings, cyclopentapeptide. So this is some crazy natural product that was isolated from endolichenic fungi. Yeah. So they can get all sorts of things. There's new technologies. They don't even know what the metabolites are. It's just crazy. You have no idea. It could be anti-cancer, antioxidant, antimicrobial, anti-Alzheimer's. And then this is my favorite story. I don't know why. I saw this lady give a talk, and now I'm gonna just basically steal it. But she went to this place, remote corner of the world, right? Guyana, northeastern corner of South Africa. There's nothing there, right? It's some of the most last remaining virgin tropical rainforests in existence. This lady, Catherine Aim, I saw her give a talk a couple years ago at NAMA, and she just went to this remote part of the jungle out there in Guyana for a couple months, and had 200 new species of mushrooms and 8 new genera, which is a genus. 8 new genuses or whatever, genera, were discovered just by her just going out in the middle, and middle of nowhere. So one of the coolest things she found, this is a relative of bread mold, okay? There's only one other species in the genus, and it exists in Japan. And it persists in the environment for up to a month. And it's ectomycorrhizal, which is weird because most things are endomycorrhizal, like Amanita or Maitake or whatever. But this is ectomycorrhizal with this crazy tree that's only down there in Guyana, right? So it's a member of the bean family. It's a megalith. They're everywhere in this remote. They're monodominant, so it'll be 20 of the same trees in the one stand. Anyway, people are going out there and researching stuff like this, and this is what I really think is awesome. We're doing this. We're extracting the medicines of you know, the mid-Atlantic and right now we live in southern Appalachia, so we're doing it all over, I would say, like, eastern part of the United States, but it'd be awesome because a lot of, like, this tree is in one part of the world, okay? The stuff that's growing with it, the fungi, is just gonna, we don't even know about it, you know? Like, it's just so weird. So, ectomycorrhizae, just as a little small refresher, the hyphae don't actually penetrate the cells like they would on, like, a Mycopharmacognosy or something. And this is just, like, the next couple of slides are, like, super big encouragement because the lady that went and discovered all of this, like crazy 200 new species and 8 new genuses, was a college dropout. She lived in DC and played in a punk band, and she was always like wanting to travel and stuff. And then she went back to school as a 30-year-old undergrad, took a mycology course in Virginia Tech, and she was like, I'm gonna go for that. I'm going for it. Like, I'm doing this. Like, I'm gonna do this. So I'm literally serious. If anyone is interested at all in like collaborating, just hit me up because there's so much people out there doing cool stuff that I have no idea about. Any of you could be doing cool stuff or going to the rainforest like tomorrow. Like, I have no idea. So if you want to get in touch with me, my email is Lady of the Rainforest, which just became extremely appropriate when I moved into the middle of the Nantahala National Forest down there in the remote corner of North Carolina recently, and then on Instagram, I'm Mushroom Madman. And I just want to give a little quote as the last slide because I love this slide, and I just know that there's just so many more discoveries out there, basically, whether it's medicines, you know, dyes, foods, whatever. Fungi are out there, and there's so much more to be discovered about them, and anything is possible. So here's a cool quote, because I'm a reader and I like reading. Out to sea, up to the moon, out to sea, to the moon, up Everest, down the Amazon, over a hillside, into a mushroom spore. Exploring the DNA that makes life what it is. If you have felt the pull of the unknown, then you understand a band of researchers tucked into hammocks, draped with mosquito nets, scratching their trigger bites as rain thrums on the tarp, who tomorrow will climb a hill to fill tackle boxes with mushrooms nobody has a name for. What they do adds piece by piece to what we know about the world. So I just want to encourage everyone to just keep putting those mushrooms in the tackle boxes, like keep going out there looking for stuff, questioning, posting, what is this? Like, it could be the next, you know, find of the decade. And we could use it for drugs, who knows? Like, anyway, thank you guys, that was it. If you guys have any questions, her talk is not for like another couple minutes, so.